Okay, share the screen, madam. Okay, so again, to give us more details about the topic, which is focused on the UMDL dynamic modeling notation. So, actually, this will be an advanced system design, no, with Java UML, the discussion of the state charts. No? So in this lesson, we complete the introduction of UML notation by describing the modeling languages used to define dynamic behavior of a system. No? So as I mentioned earlier, no, the state machines or the state charts, no, collaboration and sequence diagram. So I think it's time for us to give a chance to our presenter to discuss the detailed about that topic. Okay, go ahead, madam.
Hi, sir. Good morning. Sir, I hope you can see my presentation as well.
Yes, ma'am.
Okay, so good morning, everyone. So I am Maria Cristina Reynera, and I'll be discussing to you all about UML dynamic modeling notation under MIT 503 Advanced System Design and Implementation. So let's have a recall of the discussion of one of our classmates a while ago. So it was discussed for the prior two discussions is first is OCL is a type declarative and side effect free specification language. So meaning the type means that the OCL expression evaluates to a type and must conform to the rules and operation of the type. Then in relation to the UML meta model, each OCL expression is written in the context of an instance of a specific type. So the last one is, I think, an invariant is a constraint that should be true for an object during its complete lifetime. So for this one, it often represents rules that should hold the real life objects after which the software objects are modeled. So for today, so thank you so much for the first two presenters a while ago. So we have an idea already of what is modeling notations all about. Now we're going to start with a chapter 4. So we jump with one chapter. So it's all about UML dynamic modeling notations. For this one, we're going to talk about state charts, collaboration diagrams, sequence diagrams, and activity diagrams. So for this one, let's define first what is state charts. State charts, yeah, that one. So these focuses on the dynamic behavior of the object that represents the life behavior of objects over time and their patterns of intercommunication. So meaning we're using this one in a real-time design such as the robotics, GUI design, screen modes interface. So as you can see in my diagram, there are different elements that you can see. The first one is the round corner of boxes contains the state name. So technically, this one is the it will indicate if it's an on or off system. Now, the next part that you will be able to see are the lines in what we call transitions. So transitions are the arrows from one state to another, or the target label with event at the cause of the transition. And the last but not the least is what you call the default initial state. So that's the last one. As you can see, it's a bull's eye symbol. It's easy to identify, and that one is the termination. Yeah, the termination of the state machine. Now, in UML, it's a divided. The UML state charts is divided into two kinds. So we have the protocol and also behavior. If we're going to compare these two, the protocol is it describes allowed life history of an object of a class. Yes, it's event on a transition or operation of the class, and transition may have pre or post conditions. So the base role of this one is to define when and on which condition can individually behavior features an owning instance. But on the other hand, if we're going to describe behavior state machine, so it describes the operation, execution, implementation of an object behavior. So transitions do not have post conditions but can have an action. So in other words, to explain this one, so state machine describe the behavior of object of a particular class or execution processing of an operation. So then in my next presentation, you will be able to see, I got this graph from javatpoint.com. So it's an example of a top level machine diagram, and we know how to use ATM, right? By the way, we're not calling it ATM machine. Okay, we're calling it ATM. Okay, so first is initially the ATM is turned off, right? Then after the power supply is turned on, so the ATM starts performing the startup action and enters to the self test state. So it's like when we open our computers, we started with the AVR, then followed by the CPU, and it will be automatically open with BIOS. Now, if there is a test fail, so it will go to out of service state. So yeah, most likely you will be able to see that one on the screen if there is no money inside the machine. Okay, so whenever the customer insert credit card or probably debit card in the ATM card reader, so the ATM state change from idle to serving customer, wherein the customer will have a chance to perform the different transactions. So here in this part, in the lower part, as you can see, so here is the serving customer is an composite state with sequential substate. So we have the customer authentication, selecting transition, and transaction also as well. So for that one, so if ever that the service is already okay, so the customer will be satisfied that whatever service that she got, she will get the result. Now, after the transaction is finished, the serving customer imposes the triggerless transition back to the ideal state. So on leaving the state undergoes, it will happen now. It will discharge the customer card. So the event of this one, the one that I discussed, I know it sounds complicated, but in this one, so we're talking about the events of protocol. State machine normally corresponds to the operations or methods of the class whose behavior the state machine describes. So for as you can see, I think the best example. So you might not understand the meaning in this area, but then the best example of this one is the traffic light. May I ask from our participants who among you are driving? Yeah, you may use the chat box. Yeah, let's make it like not a traditional way of doing the report. So I would like to ask everyone to cooperate also. So may I ask who among you are driving? Yeah, may I see the chat box? I think I need to open the chat box. Na, yeah. None from our group. I hope you're still with me. Okay. There you are. I have one. So I am so happy that there's at least one who's listening to me. Oh, there are two. Okay. So for that one, may I ask, what does it mean if the light is green? Yes, you have a chance to move, right? You are allowed to you are allowed to drive. And yes, after that, and what is the next color? Before turns orange, and what is the indication if it's orange? Oh yeah, we call it, it can be red, it can be amber. Yeah, amber orange. Yeah. It's you are preparing to stop already. And last but not the least, yes, thank you so much. There we have unattended participants for today, so thank you so much for that one. So traffic lights are usually timed. Yeah, usually time or traffic response. So when the signals are operated exclusively on timers, each direction is allocated with a specific period of time. For example, there are 30 seconds, probably. Sometimes I notice that in Festival Mall, I think they only have, I'm not sure if it's 10 seconds. The one from, what do you call that one? Going to, passing by from, what do you call this one? I forgot the name of this, the one from North Gate going to Alabang. I forgot that one, but it's not really the 30 second. Yeah, 30-second type, right? So, but then yes, we are correct that one, that the green, these color signals that you will now be able to drive, right? And the amber or yellow, these color signals drivers that you need to prepare to stop. And the last but not the least, the red, is this color signals vehicles to stop in a certain point, usually to allow the passage of vehicles on the other sides and the other roads, right? For yeah, that one, the south station area, that is the one that I thought is just a 30 seconds, but I don't think that is a 30 seconds. Yeah, thank you so much for that one, Sir Marvin. Now next, so for this one, so that's an example because it has a system already. It once you go to green, amber or orange, or then red, then it will go back again to the start. So it's a green, like that. So it's a cycle. Yeah, that's the cycle. Okay, next is, of course, there will be what you call transitions, guards and actions. So transitions from one state to the another are denoted by lines with arrows. So this is the one. So a transition may have a trigger or guard on or an effect. or you can see how what is the process between the source state going to the target state. Now, the word guard is the condition which must be true in order for you to trigger to cause the transition. And the effect is what will be the action. So in the transition example that you can see right now, it's an effect was associated with the transition. So if the target state had many transitions arriving at it, and each transition had the same effects associated with it, it would be better to associate the effects with the target state rather than the transition. So for that one, so the next diagram, I think one of our classmates mentioned this one already. This is an example. The state diagram with an entry action and exit action. So this is the one I think she was able to discuss this one. Okay. Next is the following rules applies within the state machine. So what are the rules that we need to consider if we're going to use the state chart? So for this one, so state chart can occur in any order within an enclosing block, but the order in which were listed doesn't affect the order in which they run. So within the state machine, there are only one state that designated as a start state, designated by the value of the start end. That's why if we're going to go back with this diagram. So there is a starting point, right? And this state is the one that is executed first. That's the reason why all the systems, as you can see right now, there's always a starting point and also there's always an end point. Okay, so if your machine, if your machine consists of only one state, it can be both the start state or the end state. Now, when to use and not to use the state machine. So if it's an early or it's in the planning still, so that is advisable to use, and when behavior of an object or operation not well understood yet. So you can easily draw or you can easily erase things and change or probably modify the system. Now, when is not the right time to use the state machine? If there are several objects are involved, that there should be an interaction diagram instead. I think we're like that, right? If there are a lot of diagrams, you cannot really and there you cannot really understand it very well. So what is the best concept of that one with the explanation also as well? So there should be an interactive diagram also to present what we are doing, what we want to present, especially if we have clients and etc. Now, I have here a review first. Let's have a review first. I just want you to type letter T in the chat box if it's true, and F if it's false. So just a recall of my discussion a while ago. So the first question, you can just mention it through, true or false. So state chart focus on the dynamic behavior of an object and graphically represent the life history of that object over time and their patterns of intercommunication. Is it true or false? Based on my discussion, and also I think the other classmate also discussed this one a while ago. Is it true or false? You may comment T in the chat box or you may comment F. Let's see. Yeah, anyone? Anyone from our, yeah. Okay, so if your answer is C and I can see yes, thank you so much, Sir Jetro, for that one. So the correct answer is true. Yes. Yeah, remember we discussed that one, that stage chart is focusing the dynamic behavior of the objects. Yes. Okay, let's have number 2. UML divides state machine into 3 kinds. We have the protocol machine, behavior state machine, or states diagram. Is it true or false? Okay, so if your answer is false, you got the correct answer. Why is it false? So remember I discussed a while ago that UML divides into 2 class. So we have what are the 2? We have the behavior and what is the other one? Protocol. Yeah, yes, correct. So there. Yes, thank you so much. So we only have 2. That we're in the protocol, it describes states. Wait. Yeah. One of the rules applied to the states within a state machine is your state machine consists of only one state. It can be both the start and it can be both of the start and the end state. Sorry for that. No sound. Sorry. Wait. Hold on. Hold on. Can you hear me now?
Yes, madam. Yes.
Okay, sorry for that. So, what do you think is the answer? Yeah, thank you so much. What do you think is the answer? Is it true or false? Sorry for the. I think I need to rephrase that. This one. Yeah. So what do you think? Do you I think the best way if how I going to rephrase it is state machine consists of only one state. There it can be both the start and both the start and the state and the end state. Yeah, there's a lot of states, right? Okay, what do you think? Is it true or false? Yeah, let's see. Is it true or false? If your answer is true, yes, it's correct. So, right, the last, I think one of the rules and one also of the things that we need to know also that if there is one state, it can be the start and the end of the state. Okay. So moving on to the next part. So other examples of states under state charts. Yeah. This one, there's still a lot. So I just want you to, to be with me with the discussion, okay? So for this one, so the first one is the composite state chart. So this chart is like a nested within others to explain the relationships of generalization or specification and to simplify diagrams. So this is a state contains one or more substates. So it's like a state within a state. Yeah. So when a composite state is entered, yeah, its entry nodes denotes to the substate to be activated. So there are two. So this is the first one. This is another one. Yeah, there. So that's the diagram shows. The diagram shows when the switch off occurs in a state on. So it's goes to standby. So the default state is still off. But when the switch on occurs, if the system is either standby or no power, then the next state is on. So the nested state notation therefore reduces the number of transitions. Okay, so let's take a look of this one. Probably this is one we can relate this one, this kind of example. So I got this one from one of the writers. I think of the subject. Yeah, Mr. Kevin Lano. Yeah, for this one. So this is an example of a state machine of a BSc student with a three-year course with the first is the state year 1, year 2, and year 3 as a sub-state of studying. So states interrupted and terminal graduate at the level only. Why is it this one is open during the year 3 only? Because because based on the what you call that, based on the situation, that this is only a 3-year program. So technically, you will be able to graduate only if you reach already the year 3. You will be a candidate for graduation, right? So what if the person did not finish the year 2? So basically, that's why there's letter H here with a circle. So this diagram shows that the student needs to go back. Yeah. Student needs to go back or repeat what level he or she did not finish. That's how we understand the diagram. Okay. So for this one, so next is nested state. So in nested state, it is used to model the complex system as a regular state diagram is inadequate in describing the large and complex problem. So a nested diagram is a concept of advanced state modeling. So for a better understanding, I have an example here. I got this one for binaryterms.com. It's an example of a vending machine state diagram. So at the beginning of the machine is idle. I think all the machines is like that, right? It will start with the idle. Now a person comes and insert some coins into a vending machine and select an item. So if a selected item is not available or the amount inserted is insufficient, then the machine will not do the process. Right? But then if the amount is sufficient and the item is available, then the machine, that's the only time it will dispense it. Then observe the one in the lower part, right? Nested state. So we have the state already here, and under of that one, there's still a process under. So the state dispense may have multiple substates. So it is expanded to a lower level state design. So which is also termed as sub machine. So a machine with a, yeah, like that. So a term sub machine is defined as a state diagram which is triggered from one another high level state diagram to another one. So this is the higher state diagram. Then there is another one under. Okay. So this one. So the next is the history state. So history state allows the user. If we're going to notice the example a while ago with letter H at the circle, so that is part also of the history state. So you can go back with the last step probably, or two or three steps. So the diagram that you can see right now is and it's an example of a life cycle of facing a product. So if you are if you have your own business, or probably you have your own beauty products, yeah, there. So if the product development is suspended, so the state chart control is passed to the suspended state. So if it's suspended, it will go to the suspended state. Now, when the company decide to resume that one, so they can go back again to the testing. So it will run again another cycle. But then they will not they will not start anymore from the scratch, since they have a record already. So they're just going back to the testing again. Then and from then, if they think that they need to suspend, so it will just going back. So it's like a cycle. Yes. Now let's move on to the next part. Yeah, we still have another parts, which is the interaction diagrams. So for this, the interaction wait, I think I click on wrong button. Yeah, there. So for the interaction diagram, this is a type of UML that used to capture the interactive behavior of a system. So this kind of diagram focus on describing the flow of the message within the system, providing the context for one or more lifeline within the system. So in addition, for this one, interaction diagram can be used to represent the order sequence. So there's a pattern of 1, 2, 3, 4, 5, like that. So the purpose of this one, why do we have this kind of system? So of course, to capture the dynamic behavior of a system. So the next one is to easy for us to describe the message flow of the system, to also to see the structure part, or of organizing the objects, and last but not the least is the interaction among different parts of the system. So in this case, there are actually two kinds. Yeah, we have sequence diagram and collaborative diagram. So if you say sequence diagram, so it's emphasize the timing and history of the object. So this diagram consists of group of objects, or that are represented by lifelines. In the other hand, if we're going to discuss the collaboration diagram, so this is the structure aspect of interaction diagram, focusing on object architecture rather than the flow of the message. So that's how we describe that too. Now let's talk about first the sequence diagram. Now in the sequence diagram, actually there are really always five main events that you can see there: order placement, payment, order confirmation, order preparation, and order serving. So these five, if the sequence and the event change, right, it will cause delay, or probably if it will not cause delay, it will crash the system. So it is really important to select the notation that matches the particular system within the diagram. So what is the benefit of that one? Of course, it's easy for us to maintain and generate. It's easy for us to update according to the changes in the system, and allow to reverse and forwarding engineering. And the other hand, the disadvantage of this one is there will be there are things that we need to consider. There are a lot of things because of the complexity. Complex parts of the system, and also it's easy to produce incorrect and dependent on the sequence of being entered correctly. So for the other hand, so if we talk about collaborative diagram, we talk about three parts: so objects, links, and messages. For the objects, so particularly in a collaboration with the two things, we have the supplier and also the client. So if we talk about supplier, these are the ones the object that supplies the methods. Okay, and if we call it clients, so these are the clients calls methods on the objects and therefore send messages. So we have also the link. So link is the connection between the object and object to object, sorry, object to object. So these links are set to set collaboration diagrams apart from the sequence diagram, so they enable to see the relationship between the different objects. Now the last one is the messages. So messages in collaboration diagram are shown as an arrow pointing from the client. Later on, I'll be showing you an example for this one. So what is the advantage of using the collaborative diagram? So it can be a I emphasize how Lifeline connects. It can focus on elements within a system rather than the message of the flow, and they provide an added emphasis on organization or over timing. But then, of course, there's also a disadvantage of this one. So they can become very complex. They can make it difficult to explore specific object, and they can be time consuming to create. So for the last but not the least, so this will be the last part of the diagram, which is the behavioral diagram. So what do you mean by what do you mean by this kind of diagram? So for the last part, so behavioral diagram, this is the one wherein it is used to, for a case diagram or sequence diagram, show how the system works in motion. Okay, so as you can see, what is are you familiar? Of course, everyone familiar with the flow chart, right? It looks like the same, but we're going to discuss. Okay, we're going to discuss the differences of these two. Because later on you might be confused that what is the difference of this one behavioral diagram and the flow chart also as well. So for the activity diagram represents the five benefits of the users. It demonstrates the logic of the algorithm, the steps for the UML use case, the business process, the processing by clarifying complicated use cases, and model software architectures. So those are the things that they're focusing. Now, what are the basic components of this one? So wait, hold on. I think I missed the the slide. Sorry. So for this one, so as you can see, activity diagram, it is used to illustrate the flow of the control in a system. So as you can see, like I mentioned a while ago, it looks like the same with flowchart. However, for the activity diagram, they have a big differences for this one. So for this one, as you can see, we're going to discuss also the parts in the next slide, I think. Yeah. But we're going to talk about first about the basic components of an uh, activity diagram. So for the first action is action, decision mode, control flow, start node, and end node. So the first is the action. So an action is the step in activity wherein the users or software perform a given task. So the next one is the decision wherein a conditional branch in the flow that is represented by the diamond. So we know in doing a programming, we usually use the diamond symbol for creating a decisions. Of course, to control the flow, we are using arrows, but we call it control flows. And the start node, of course, it will start the diagram. And but this time we're using the bullseye symbol for for the start node. And the last but not the least is the outline black circle, which is the end node. I have an example. I think this one, in this case, wait, this one. So these are the symbols, as you can see. So same, right? Almost the same with the flow chart. However, these are the differences of the two. So at least you will know later on what are the how are you going to compare these two. So the what are the difference of this one? So in as you can see, comparing these two, so I got this one for pedia.com. So they describe an activity diagram is a graphical representation of work flows of stepwise activities and action with the support for choice. For the flowchart is a representation only of illustrate a solution model to given problem. So in the activity diagram, it helps to understand the business process flows. And this one is for the flowchart. It focusing with the designing. And the last but not the least is the activity is connected with the UML, and the flowchart is associated with the programming. So in the conclusion of these two comparisons. So the main differences between the activity diagram and the flowchart is the activity diagram is a UML behavior diagram that represents the workflow of stepwise activity of the system, while the flowchart is a graphical diagram that represents the sequence of steps on how to solve a problem. So that is the difference of the two. So there. So before we conclude, so I'll giving you an example. So as you can see, this is an example of the basic flowchart that we usually do when we do in our, in our undergrad courses. But this time, if it's activity diagram, this is more detailed. It talks about the activity of the system. This one, it only discuss uh the flow on how to solve the problem. So that's the difference of the two. Okay. So before, I think the last is the chapter summary. But before anything, before we go to the chapter summary, let's play first. Yeah. Let's make our life. Yeah. Let's make our life lively, like a yeah, I think 5 minutes only before we end this one. I would like to ask everyone to join myquiz.com. I only have 5 items here. I'll be sharing the link also as well. So kindly click the link below. Then kindly type your name. Yeah, this is only a five item, just to wrap up the last part of the discussion. Let's see. I think as of this moment, there's none. Yeah, because still zero. I hope everyone. I hope yeah, there I can see one. Thank you so much, Sir Jetro. Yeah, there, Sir Marvin, Sir Darwin, Sir Mark. Yeah, thank you so much. Okay, so let's just a review of what I discussed a while ago. Just a very basic one. Okay, so we'll start. Then later on, after you play this one, we're going to discuss the what you call the questions and the correct answer. Okay, so I'll click the start. There, I think there are still we have 6, and we on our call we are 16. Okay, there, I think. Okay, the others I think can join also later on. So let me click the start. Yeah, I just need to choose the correct answer. Yeah. Yeah, you can use the power up for that one. It's okay if you got incorrect answer. We're just going to discuss still the questions later on. Yeah, go Sir Bong. I think Sir Bong's still answering. Yeah, it's okay. Again, it depends upon you the answer. Yeah, with your understanding. Anyway, we're going to discuss still the questions later and after we play the game. Okay, yeah. Go Sir Bong, Sir Ma'am Bev, yeah, Sir Alex, yeah. Ma'am She also. I think that we're done. Oh yeah, we're done with the first one to yeah. Let's see if the ranking will still change. Yeah, because Michelle is not yet done answering. So let's see who will be our first. As of this moment, Sir Jet. Yeah. Okay. Let's see. I think is it still moving? I think they're still answering. Yeah, I hope Miss Shen, Sir Bong, are you still yeah, you can still answer the last item. I think it's the last item for this one. So probably we can end already this one. Yeah, we can end the game. I wait, they're still answering. Wait, I think not anymore. Okay, I think it's not moving. So let me end the game, and I would like to congratulate Sir Jet for the getting the first rank. Second rank is Sir Marvin, and third is Sir Edmund. So there. So for the I so don't worry. So we're going to review the questions. So the first one. So the first one is what is an interaction diagram? So yes, interaction diagram is a UML notation for dynamic modeling. So next is an interaction diagram is a central focus of engineering design. And of course, these two is all of them mentioned. Okay. Next is next question. What is a sequence diagram? So it's a flow. Yeah, this shows the interacting individuals along the top of the diagrams and the message pass among them and arrange them in temporal order down of page. Okay. So the number three is which of the following is true? Actually, everything. Yeah, all of the mention is true. Yeah, the transition is a change from one state to another. Transitions may be spontaneous, but usually some event triggers them, and an event is a noteworthy occurrence at a particular time. So number four question: which of the following diagram is time oriented? That's why when you say the word time, it's what you call a sequence. Okay. And last but not the least, which diagram is used to show the interaction between members is classified as collaboration. So there. So there you have it. So like again, congratulations, Sir Jet, Sir Marvin, and Sir Edmund for getting the first three rank. Now let's go back for the last part of my discussion. It will be the chapter summary. So this very short. Yeah, I think based on the things that I discussed, I think these are the three important things, three or four. I have five. Yeah, five important things that we need to consider in UML dynamic notation summary. So first, use cases describe functional requirements. Number two, class diagrams define data of system. Number three, OCL allows expressions of detailed functionality and data properties. Number four, state machines plus activities can precisely describe the behavior. And last but not least is the sequence diagrams that can give examples of behavior. So with that, I would like to say thank you so much for everyone for participating, and thank you so much also, Doc Marmelo.
Thank you, ma'am.
Okay, thank you very much for a well presented discussion and again as I mentioned earlier most commonly especially in our field in education that the UML notation was always applied in our field so our presenter discussed the elements of the state chart the states written as rounded corner boxes this have named the transitions the default initial state so termination of a state chart can be shown again, of course, of the bullseye symbol, no? And the UMD divides state chart into two kinds: the protocol state machine, which describe the allow life historics of objects for a particular class. So in this case, the event on transition correspond to operations of that class, and transition may have pre and post conditions actually. No, and in addition to any that are defined in the class diagram, implicitly the transition precondition is conjoined to that of the operation for the given starting state. No, likewise for the post condition. So that is of course the transitions of actually, no, and again our presenter discussed the additional, no, inputs or related to the topics. Okay, so I think that's it for the discussion of Madam Rinera. So congratulations and thank you po for your presentations.